All right, this is our last day of chapter 14. So this last section is going to talk about how you can compare different acids and bases and compare their strengths just purely by how they're bonded together and how they're structured. So first of all, just notice that not every compound that has a hydrogen is acidic. So if you look over here, I have it drawn off to the right. This compound does have a hydrogen, but because carbon is not very electronegative, it's not pulling on the electrons very hard, and so hydrogen doesn't end up becoming very positive. And therefore, hydrogen is not very attracted to the oxygen in water. So again, it's a competition for the hydrogen, whether it's going to stay on the acid or be attracted to oxygen in water. And so in this case, it's not going to release that hydrogen, and so it's not going to be very acidic. However, HCl is very polar, so it's a strong acid. And it actually has a stronger bond than the HC, which is weird because you think if it's a strong bond, then the H won't break off. But even though it's a stronger bond than the HC, it's very polar because chlorine is electronegative, and so it's pulling the electrons away from hydrogen, which makes hydrogen very slightly positive. And so it's that slight positive from the hydrogen that makes it attracted to the oxygen in water. And oxygen is more electronegative than chlorine, if you look at the periodic table. And so hydrogen is more attracted to that oxygen. So again, it's a competition, and the oxygen wins for that one. Some other factors you can look at. So it's pretty common that you'll see questions listing several acids and asking you to rank them in terms of strength. Which one is the strongest? Which one is the weakest? Obviously, you should look for the 6 strong acids first. But then beyond that, you could talk about some of these factors. So one is the strength of the bonds. If it's a stronger bond, then it's not as likely to break apart, which means it would not be as acidic. You could also look at the polarity. So the more polar something is, the more positive the hydrogen is, which means the more attracted it is to oxygen in water. And so in general, if it's an extremely polar bond, then meaning that it's attached to a very electronegative element, then the hydrogen is likely to break off, so it will be more acidic. You also can look at the size of the atoms. So bigger atoms tend to have weaker bonds. So if you look at these H compounds, so you got HF, HCl, HBr, and HI, notice that HF is the most polar. So you would think, well, if it's extremely polar, then hydrogen is going to be really positive, so it's going to be very acidic. It'll break off and bond to oxygen. And HF is not on the list of strong acids. All the other halogens, so chlorine, bromine, and iodine, those are all strong acids, but HF is not. It's a weak acid. And so it's important that you understand why this is kind of an exception to the rule. So even though HF is very polar, it's a weak acid because, well, there's 2 reasons. One is that fluorine is more electronegative than oxygen. So remember, it's a competition, and so the hydrogen is more attracted to the fluorine than it is to the oxygen. And then the second reason is because fluorine is really, really small. So the size of the atom kind of makes fluorine an exception to a lot of the rules. Here's some other things you can compare. So if you have this molecule form where you have hydrogen and then bonded to oxygen and then bonded to X, so anything else, if X is really electronegative, then it's going to pull the electrons away and make hydrogen very positive, and so it would break between the hydrogen and the oxygen. So you would have that break right here. And so that would make it acidic. If X is low in terms of its electronegativity, then it's going to break here, and the OH will break off, which will make it more basic. And the more oxygens you have around X, so in this example down here, chlorine is the X, so notice that there are 0, well, there's 1, but there's 0 other oxygens around it. Over here we have 1, now we have 2 more, and now we have 3 extra oxygens. So as you add more oxygens around them, the oxygens are pulling the electrons away from this bond right here, right between the oxygen and the hydrogen, which makes that attraction weaker, and so basically it makes hydrogen more positive, and so it's more likely to break off. And so the more oxygens you have, so this one right here, this is actually a strong acid, is going to make it stronger. There's a few other reactions down here. You can see that if you have a nonmetal oxide, so some nonmetal bonded to oxygen, and you mix it with water, it's going to create an acid. If you have a metallic oxide, so a metal bonded to oxygen, then when it reacts with water, it always creates a hydroxide compound. So those are just some common reactions that you should be familiar with. And then the last thing, these are just, it's a summary of what you should do to solve these problems. But really, it just takes some practice. And so the more you do on those progress checks and understand how to solve those, the better you'll do. And you don't have to go through this step every time. You'll just know exactly what to do for each one. So good luck solving those problems, and I will see you in class.